Hello, Dr. Joe. Our group will be presenting on Machine Learning Project Assignment 2. The members are Nicholas, me, Darren, and Ricky. The assignment title is Image Classification with Supervised Machine Learning Scenario A, which is about the animals. This is the table of contents we'll be talk about. First of all, the instruction to run the code is when you go inside the terminal, you type cd animals classification on animals 10 dataset using VGG16man, and then you can run it by typing python app.py in the terminal. For data preparation and pre-processing, we are using the animal 10 dataset from Kaggle. Why we use this dataset? Because it is balanced across multiple animal classes. It contains real-world images with diverse backgrounds and perspectives. These images are more similar to what a deployed application like wildlife monitoring or animal recognition might encounter. It is also ideal for image classification using convolutional neural networks, which is CNN. How many classes and how did our group obtain it? So there is 10 number of classes. Each folder in the dataset corresponds to a class. You can see from the photo there, it could show the class labels for dog, horse, elephants, butterfly, chicken, cat, cow, sheep, spider, and squirrel. How did we obtain this dataset? Is by downloading it directly from Kaggle after agreeing to the license term, which you can see from the photo below. For the pre-processing steps, we have attached 3 photos at the side. For the first one, we resize all images to a uniform shape, which is 224 times 224 pixels. VGG16 and ResNet50 both require fixed size input of 224 times 224 pixels. So this steps is for consistency in training. And then it is also converted to grayscale or normalized RGB depending on model input requirements. Augmented data using techniques like rotation, flipping, and zooming is used to improve generalization. You can see from the second photo where it says rescale equals to 1 per 255. Both models use different pre-processing steps like VGG convert to RGB, ResNet convert to BGR. It is also can be seen at the third photo. What are the potential applications that can be created from applying machine learning to this dataset? It can be used for assistive technology for visually impaired individuals to identify animals. Secondly, surveillance system to monitor animal movement in farms or zoos. Hence, it can improve safety and reduce manual work. Thirdly, it can also use on veterinary tools in animal shelters or clinic. Quick identification and categorization, even by breed or species, can assist in digital record keeping. Now I'll pass it to Nicholas to talk about training.
Good morning, Dr. Joel. So I will be presenting the training part of our program. What type of machine learning algorithm can be used? So we do 2 convolutional neural network deep learning model. The first one is Visual Geometry Group 16 and ResNet50. And another traditional machine learning model can be used support vector machines, random forest, and k-nearest neighbors. But they require features extraction tool like the histogram of oriented gradient to extract the feature of the image to allow this machine learning to classify animal images. So how do these algorithms work? So for VGG16, this model allow a clean stack approach from convolutional to ReLU, max pooling, fully connected, and to softmax. And it uses small 3x3 filter and it is for capturing fine image detail with high efficiency, and it contains 13 convolutional layers and 3 fully connected layers. And the model reduces image size to lower computation while preserving the key feature. For ResNet50, it uses skip connection to allow the data to skip across layers. And this skipping connection solves the vanishing gradient problem in deep network. So what classifier have you chosen? So we import a pre-trained VGG16 model and pre-trained ResNet50, and they are trained on ImageNet over 1 million images. And we just use a transfer learning to adapt them to our animal dataset. So the classifier training procedure, so we do the preprocessing first. We resize the image to 224 times 224, and we apply their respective preprocessing, and we split the data into 85% for training, 15 for validation. Then we load the pre-trained VGG16 and ResNet, and we freeze the base layer, the last 4 layer, and we add our custom layer for classification. Then we train our model. Then lastly, we evaluate the performance of our model. So parameter we choose for our classifier. 224 times 224 pixel for image size, 32 batch, and 5 epochs. And our optimizer is ADEM, and learning rate of 0.0001. Metric such as accuracy, recall, precision, F1 score, and area under the curve, ROC. Validation split is 15%, and the augmentation such as zoom, horizontal flip, and rescale. So for the evaluation part, so the evaluation procedure is first we prepare the test data. We use separate test data set not seen during training or validation. Then we do like the prediction on our pre-trained model first to see if it can accurately predict the image of our dataset. Then we evaluate the performance, calculating the metrics, and then we analyze the result to check for any overfitting or underfitting. Then we compare the performance between our VGG and ResNet. So these are the metrics that we use to measure for the performance for our model. First one is accuracy. Then we do the precision, recall, and F1 score. These are all from the classification report for each class. For the dataset, we have 10 classes, so we have 4 metrics for each classes. And lastly is the area under the curve for each classes as well. So for the result for each dataset and classifier, the first one, accuracy for VGG16 is 76%, and the same for the macro average F1, and the vector average F1 is 75%. And the best class is spider, and the worst class is butterfly. For ResNet 50, the accuracy is 95%, macro average is 96, and vector is 95. The best class is dog, elephant, and spider, and the worst class is sheep and cow. And the next part will be discussion, and this will be presented by Ricky. Thank you.
Our overall results shows that both VGG16 and ResNet15 achieve decent accuracy in classifying animal images. However, ResNet15 slightly outperformed VGG16 in terms of generalizations and validations accuracy. This suggests that ResNet deeper architecture and residual connections were more effective for this dataset. One key limitation is the small dataset size, which may reduce the generalizations ability of our models. Additionally, VGG16 show signs of overfitting on certain classes, and likely due to the limited number of training samples per class. More data or more balanced augmentations could help address this. Yes, improvements are possible. We could fine-tune more layers instead of freezing most of the pre-trained model, use better augmentation strategies, or even try assemble methods that combine predictions from multiple models. Increasing the dataset's size will also help enhance model robustness. Data preprocessing and model training can be optimized. For example, automating hyperparameter tuning using tools like Research or Keras Tuner could improve performance. Additionally, using more advanced augmentation techniques and better class balancing could help the model generalize better. Yes, the number of class and the type of the preprocessing significantly affect performance. More classes increase the complexity of the classification task, while inadequate preprocessing may cause the models to misinterpret image features. Tailored preprocessing like color normalizations and object focus cropping could help. In conclusions, our machine learning models successfully classify animal images with reasonable accuracy. ResNet 50 performed better overall, showing strong potential for real-world use cases like real-life monitoring and assistive technology. Despite some limitations, the project demonstrates the value of transfer learning in image classifications. Here are the references we used during our project. They include implementations guides for VG16 and ResNet, as well as detailed explanations from trust sources like G4G's, Median, and Ultralistic. Thank you for your time and attention. We are happy to answer any questions you may have.
I'll be doing the demo for our program. So first step we do is import the required libraries such as NumPy, Pandas, TensorFlow, Matplotlib for visualization, the libraries from TensorFlow, and Sklearn to do the ROC curve in the classification report. Then next one is the translation. Because our dataset is in Italian, the classes, so we translate it to English. Then next one is parameter, batch size, image size, and the directory of our dataset. Then the data generator for each model. VG16 use rescale, and ResNet also has its own preprocessing function. So this is data generator, and this is for the training and validation train generator and validation generator. And ResNet also have the train generator and validation generator. Then this is where we bring the sample image from the pre-trained model to see if the model can predict the image from our dataset before we go any further. And the above one is BGG. Here is the ResNet 50. Then we load the pre-trained model from MegaNet. Then we freeze the bottom layer of the model to 4 and make it untrainable. Then we define the model callbacks, such as we do model checkpoint and early stopping for each model. Then we compile our model. Then we train it for epoch 3 only, and ResNet 50 as well. Next one is the evaluation of the model loss and model accuracy. Then we evaluate the model by doing the classification report, the precision, recall, F1 score, and support for each classes of each model. This is VGG16, and this is ResNet 50. Next one is to show the misclassifier label for our model. So these are the total number of misclassified image from our model from this dataset. And this is to show some sample one. Like this one's dog but predicted cow, but this one's dog and predicted cat. Yeah, only show 10. And this is the ROC curve for the model. And this one is the same one. This is the average. Then we save our model. Yeah, so next one I will show the live demo. So this is the live demo for our program. So here you can choose VGG16 or ResNet50. So first we try the VGG16 first. Then we choose our image. Choose it. Then we click classify. Then the result will show you the predicted class. And you can return. And we choose ResNet50 and show you the result again. We can try other. And this our model predicted dog. Okay, that's good. Alright, ResNet50 is quite accurate, then I try one more. Okay, VG16. What happened? Okay, that's it for our live demo. Thank you.